Welcome to Study Loop.
Hi everybody. We need to knowing that the sphere is observed in the process about the vertical axis and sense indicated from AB forms, and the vertical determine the rate of spin of the sphere about the AB. Okay. And so for this, we need to calculate the angular velocity. So we have phi, or what we can write is my favorite way to write this. It's just like that, equals 2 pi n over 60. And n is just the number of turns. And so for this problem, it just does 60 RPM. So I put 6. Let me actually write 60 RPM. There we go. Over 60. And as this is going to be 6.2832 radians per second. And I'm going to take a point A as an origin, consider the coordinates, and consider the coordinate system with z-axis taking along the rod AB. So what that means is when we have here, I'm just going to go here, and this is going to be our little radius circle. That's really bad circle, but it's okay. We'll get the job done. We have C, X, and here we have your phi that we just found, your B, your beta, and your capital phi. Okay? And so to find this particular phi here, we're just going to do phi sine beta I minus phi cosine beta k. And the rate of spin in the z-axis. So for this, we need to find your xi plus yj plus zk. And this is going to equal here. And I'm just going to write it down here, by the way. It's just easier. Oops, and that. There we go. So from this, we don't have a j component, and we can just fill in what the w is. Sine beta I plus negative phi, capital Phi, minus phi cosine beta of k hat, okay? And okay, so now I'm going to express the angular momentum of the sphere, which is going to be HA equals IX, X plus IY, W, Y, J, oops, we've got the I here, hat plus IZ, W, Z, K, okay? And this is going to cancel out, so obviously we don't have a Y component. And this is IX phi sine beta I hat minus IZ phi plus phi cosine beta k hat. And so what we have to do is, so what we have is your HA dot is going to equal to your here cross product of HA. And so that is going to equal to phi sine beta I minus phi cosine beta k hat cross product of I x phi sine beta I minus IZ phi plus phi cosine beta k hat. And and we're just gonna scroll down. What we have is your I, and in your I we have phi, sine, beta. Here we have I, x, phi, sine, beta, and we have 0, 0 for your j component. And for our k component, we have negative phi, cosine beta, I, z, phi, plus phi, cosine beta. And so you just do your normal cross body product solution here, and what we can conclude is, let me just make it look nicer, and I'll just do the first step and I'll let you guys simplify it from there. So I is going to be, obviously, it's just going to be, because what we're doing is doing this over here, and let me just, your I is going to be this, so it's just going to be 0 minus 0, and then we have minus j, and let's just do green, and your green j is going to look at this and this, okay? So from this, we have negative I, z, phi, sine, beta, phi, plus phi, cosine, beta, minus phi, I, x, phi, sine, beta, now let's get that sine looking nice, sine, beta, cosine, beta, okay? And plus, we can do plus k, and your k is actually going to be 0, because we're just looking at this, so it's going to be 0 minus 0. So, and I'm just going to do the simplified version. You guys can do that yourself. So sine beta minus I z phi phi, and that cannot make a trident, save my life, plus I x minus I z phi squared cosine b times 2. You can always take out a phi as well. Okay. So now I'm going to take the moment of external force about A. So with that, we have your mass times gravity, cross body of C sine B. And so from this, what we have is maybe HA equals MA. And what we can do is actually, for HA, is we're going to plug in this. So from that, we have sine beta I z phi, and we're just going to try. There we go. Let me just rewrite this too so you guys can tell what it is. There we go. Plus I x minus I z phi squared cosine beta j hat, and this little hat here, equals, and this is going to be negative m g c sine b, and the j hat, okay? And it looks like what we can do is cancel out the sine, the j's, sine, and the negative, of course, and the j's. So, and now we have, oops, that's that, a negative. There we go. Now we have negative I z phi plus ix minus iz pi squared cosine beta equals mgc. And now we want to solve for here. So we get that as ix minus iz pi squared cosine beta minus mgc I z phi. And now we just need to find your I z, and that's going to be 2/5 mr squared, and that's going to be 2/5 times m of 4 inches, and 4 inches squared, which is going to be 6.4 inches squared, divided by 144 inches squared, you want feet, m equals 0.44, no, there's a 0 here, 0.44 feet squared m. And now your ix is going to equal to 2 pi mr squared plus c squared m. And in here we have 2/5 m 4 inches squared plus 10 plus 4 inches squared m. And now we have 202.4 inches squared divided by 144 inches squared m equals 1.4056 feet squared m. And your c is just going to be 10 plus 4 inches, which gives us 1.1667 feet. And now we can go back to this equation and have that equal to 1.4056 minus 0.0. Oops, let me just fix that here. 0.0444, and we have m feet squared. And so, and this is times by 6.2832 radians per second squared times cosine at 20 degrees divided by, oops, and we forgot one more step. So minus, we've got the MC, m times 32.2 times 1.1667. There we go. Okay, now divided by 0.0444 feet squared m times 6.2832, and here we have 50.4974 m minus 37.5677 m divided by 0.2789 m. And here we get 46.3 radians per second. And now we can calculate your n, which is going to be 60 times your phi divided by 2 pi. And so we have 60 times 46.3 divided by 2 pi. And we get 442 RPM. And that is your answer, guys. Thank you.